You have a memory of waking up this morning. You remember where you slept. You remember what happened yesterday. You remember last week, last year, your childhood, your first day of school, the faces of people you love, the accumulated texture of an entire life lived forward. From a beginning, you can trace back to your earliest awareness. Those memories feel real. They feel continuous. They feel like evidence. Evidence that you exist, that you have always existed, that the world around you is real and has been real for as long as you have been in it. Now here's the question that has no comfortable exit. What if those memories appeared 5 seconds ago? Not gradually, not through the normal accumulation of experience, but spontaneously, fully formed. A complete set of false memories of a life that never happened, assembled from quantum randomness in an instant, arriving in a brain that fluctuated into existence moments ago, complete with everything it needed to feel like a real person with a real past. You would not be able to tell the difference. The memories would feel exactly as real as they feel right now. The sense of continuity would be identical. The conviction that you exist, that your history is real, that the world around you corresponds to something genuine, all of it would be indistinguishable from what you are experiencing at this moment. And here's the part that physicists cannot argue away. In a universe old enough, large enough, or infinite enough, a universe that continues for long enough after the last star burns out, this is not just possible. The mathematics says it is statistically inevitable, and it says something else that is far more disturbing. It says that in such a universe, the number of these spontaneously fluctuating false minds vastly, incomprehensibly, irreversibly outnumbers the number of real ones. Which means that if you are the kind of conscious being that statistics predicts should exist in a universe like the one our best models describe, the most likely version of you is not the one with a real history. It is the one that appeared moments ago with a false one. This is the Boltzmann brain. And it is not a thought experiment invented to be provocative. It is a genuine, technical, unresolved problem in cosmology that has broken several otherwise promising theories of the universe, and that the most careful physicists working today have not been able to dismiss. Let's build the argument from the ground up. Because to understand why the Boltzmann brain is a real problem and not just a philosophical curiosity, you need to understand where it comes from. And it comes from the deepest and most serious places in physics. Start with Ludwig Boltzmann, one of the greatest physicists of the 19th century, the man who more than anyone else developed the statistical interpretation of thermodynamics, the framework that explains why entropy increases, why disorder tends to grow, why the arrow of time points in the direction it does. Boltzmann spent decades working out the mathematical relationship between the microscopic behavior of particles and the macroscopic behavior of the systems they compose. His work was foundational. It is still foundational. And it contains, buried inside it, the seed of one of the most disturbing ideas in the history of science. Boltzmann understood that the second law of thermodynamics, the law that entropy increases, is a statistical law rather than an absolute one. It describes what is overwhelmingly likely rather than what is physically necessary. The probability that a shattered glass spontaneously reassembles is not zero. It is just so close to zero that it will never happen in any timescale that human intuition can grasp. But in an infinite universe, running for infinite time, every configuration of matter and energy that is not explicitly forbidden by the laws of physics will eventually occur, including configurations that are extraordinarily improbable. Including configurations that are so improbable, they make the entire observable universe look like a statistical certainty by comparison. Boltzmann himself recognized this, and he recognized something that follows from it. In a universe in thermal equilibrium, a universe that has reached maximum entropy, the cold, dark state of the far future. The only deviations from uniformity are random fluctuations. And random fluctuations, given infinite time, will eventually produce everything, including stars, including galaxies, including planets, including life, including conscious minds. But here's the crucial point that Boltzmann's own work implies. In a universe of random fluctuations, smaller fluctuations are exponentially more probable than larger ones. The probability of a fluctuation decreases dramatically with its size and complexity. And a conscious brain, a mind with memories, with awareness, with the capacity to ask questions about its own existence, is a vastly smaller fluctuation than the entire observable universe. It requires far less order to spontaneously assemble a single brain than to spontaneously assemble a universe capable of producing brains through the slow processes of cosmic evolution, stellar nucleosynthesis, planetary formation, and biological development. Which means that in a universe running long enough to produce fluctuations at all, the ratio of spontaneously fluctuating brains to real brains, brains that developed through genuine physical and biological processes in a real universe, is not just large. It is incomprehensibly, overwhelmingly, irreversibly large. For every real brain produced by genuine cosmic evolution, the mathematics predicts an essentially infinite number of Boltzmann brains flickering into existence in the thermal noise of the far future. In such a universe, if you are a randomly selected conscious mind, the probability that you are a real mind with a real history is essentially zero. The probability that you are a Boltzmann brain, a fluctuation in the thermal equilibrium of a dying universe, equipped with false memories of a life that never happened, is essentially 1. Now here's the response most people reach for at this point, the reassurance that feels obvious. We can be confident we are not Boltzmann brains because we observe an ordered universe around us. A Boltzmann brain that fluctuated into existence in the thermal equilibrium of the far future would find itself surrounded by emptiness, not by stars and galaxies and planets and other minds. The ordered universe we observe is evidence that we are real, that we developed through genuine cosmic processes rather than spontaneous fluctuation. This response is reasonable. It is the response most physicists reach for, and it has a problem that the mathematics does not let you avoid. A Boltzmann brain that fluctuated into existence with false memories of an ordered universe would make exactly the same observation you just made. It would look around, observe what appeared to be an ordered universe, and conclude that it was not a Boltzmann brain for exactly the same reasons you are concluding that right now. The observation of apparent order is part of the false memory package. It is not independent evidence. It is precisely what a sufficiently complete false memory set would include. The reassurance and the delusion are indistinguishable from the inside. Every sensory experience you are having right now could be part of the false memory package. Every perception of an ordered world, every feeling of embodiment, every sense that there are other minds around you living their own real lives. All of it is consistent with being a Boltzmann brain whose false memories include the experience of existing in a real universe. The false memory set does not need to be obviously wrong. It needs to be internally consistent. And an internally consistent false memory set of a life lived in an ordered universe would feel exactly like what you are experiencing right now. This is why the Boltzmann brain problem is not a philosophical puzzle waiting to be dissolved by careful thinking. It is a structural problem with the argument from experience. The tools we use to convince ourselves that our experience is real, sensory observation, memory, the apparent consistency of the world, are exactly the tools a Boltzmann brain would also possess. The argument from experience proves nothing about whether the experience corresponds to reality, because a sufficiently detailed false experience would generate exactly the same argument. There is no observation you can make, no memory you can access, no reasoning you can perform that definitively closes the door on the possibility that you are a Boltzmann brain. The argument has no exit from the inside, but here's where the problem moves from personal philosophy to scientific crisis. The Boltzmann brain is not just a puzzle about individual consciousness. It is a test that cosmological theories must pass, and it is a test that several otherwise promising theories have failed. Any cosmological model that predicts a universe which continues for long enough after the last star burns out, a universe in which the thermal equilibrium of the far future persists for a sufficient duration, faces the Boltzmann brain problem directly. Because in such a universe, the number of Boltzmann brains eventually produced by random fluctuation exceeds the number of real observers produced by genuine cosmic evolution, which means the theory predicts that a randomly selected observer in that universe is almost certainly a Boltzmann brain, which means the theory predicts that you are almost certainly a Boltzmann brain, which means the theory is almost certainly wrong. Because if you are a Boltzmann brain, your observations, including the observations that led you to develop and test the theory, are false memories rather than real data. A theory that predicts its own observers are probably hallucinating is a theory that has undermined its own foundations. This argument has been used to rule out or significantly constrain several approaches to cosmology. Eternal inflation models that produce an infinite future face it. Models of the universe that assume a static thermal equilibrium eventually prevails face it. Even some versions of the multiverse face it. The Boltzmann brain problem is one of the reasons that cosmologists take the question of the universe's ultimate fate so seriously. Not just because of what heat death means for the future of life, but because of what it means for the reliability of scientific observation in any theory that allows the universe to run long enough. Some solutions have been proposed. One approach argues that the universe will not actually reach eternal thermal equilibrium, that some feature of the cosmological constant or the ultimate fate of dark energy will prevent the conditions that allow Boltzmann brain production from persisting indefinitely. Another approach argues that the measure problem in cosmology, the question of how to count observers in an infinite universe, is not yet well enough understood to draw definitive conclusions about the ratio of Boltzmann brains to real observers. Another approach bites the bullet and accepts that, in some cosmological frameworks, Boltzmann brains dominate, and treats this as a reductio ad absurdum argument against those frameworks, rather than evidence that we are Boltzmann brains. None of these solutions is fully satisfying. None of them has been definitively established. The Boltzmann brain problem remains open. And the honest position, the one Cosmora always takes, is that this is a live and unresolved area where the most we can say is that the problem is real. It is taken seriously by serious physicists, and it has not been cleanly resolved, which leaves us somewhere quietly devastating. You are conscious. You have memories. You have a sense of self that feels continuous and real and grounded in a genuine history. These are the most intimate facts of your existence, the things you are most certain of, the foundation on which everything else you know is built. And the mathematics of statistical mechanics, applied to a universe old enough or large enough to produce random fluctuations of sufficient complexity, cannot confirm any of it. Not because it has proven you are a Boltzmann brain. It has not. The probability that any individual mind is a Boltzmann brain in the current universe, before the far future conditions that would make them statistically dominant, is extraordinarily small. The problem is most acute in theories about the far future and infinite universes rather than in the present moment of a 13.8 billion-year-old cosmos. But the impossibility of ruling it out, the structural fact that no observation, no memory, no experience can definitively close the door, is itself the most unsettling thing. Not the probability, the unanswerability. You cannot prove from the inside of your own experience that your experience corresponds to reality. This is not a new observation in philosophy. Versions of it go back to Descartes and his evil demon, to Buddhist philosophy and the nature of illusion, to every tradition that has ever questioned the reliability of perception. But the Boltzmann brain gives it a physical grounding that philosophy alone cannot provide. It is not just an abstract skeptical argument. It is a consequence of the laws of thermodynamics applied to a universe with a long enough future. The ground beneath certainty is statistical, and statistics, given enough time, produces everything. If these are the questions that follow you out of the room and refuse to leave, the ones that make the ordinary experience of being conscious feel suddenly strange and unverified, then Cosmora is exactly where those questions live. Subscribe and stay. There are more foundations left to examine, but before we close here is the thought that belongs to you now. You are going to finish this video. You are going to go about your day. You are going to have experiences that feel real. Interact with people who feel real. Make decisions that feel like genuine choices made by a genuine person with a genuine history. And the Boltzmann brain problem will not follow you into those moments in any practical sense. You will not be paralyzed by it. You will not be able to live as though it might be true. The human mind is not built to operate under that kind of uncertainty, and it shouldn't try. The practical and the philosophical are different domains, but somewhere at the back of everything, underneath the certainty that feels most solid, beneath the memories that feel most real, behind the conviction that you are exactly what you think you are, there is a question that the mathematics places there and that no observation can remove. Are you real? Not in the sense that you feel real. You feel real. Whatever you are, you feel real. That much is certain. But feeling real and being real are two different things. And the universe, in its vast, cold, statistical indifference, does not guarantee that they are the same. It never has.